Thank you, everybody, for joining me today. My name is John Sofra. I'm the Director of Sales for the ICE team. We call it ICE as in industrial market, the environmental outdoor market, and the commercial market. So we like to term that ICE. And what we want to talk to you today about is our noise block modular acoustic panels. And it's an interesting product in that you can use it for many applications. It's the same product used over and over and over in different configurations, but to solve many different noise control issues. And as we progress through here, hold on, let me activate my screen. There we go. So, people say, what are noise block panels? Noise block is Kinetics trade name, and it's basically an acoustic double wall panel. Means there's two walls. There's a perforated wall and a solid wall. Sometimes there's two perforated walls, and sometimes there's two solid walls. But basically, it is two metal walls of material, and then within that material is some inner shell or acoustic media that can absorb sound. There's different types of media we used. We have indoor media, outdoor media, whether it can be exposed to the elements, whether it's more of a wicking material, or whether it can be indoors, and that's the only application it has. It's also of specific densities. The infill is of specific densities to give us the tuned acoustics that we need. And if you look at this panel, it has a solid frame system around it. The skins are roll formed to then slip onto this outer frame. The frame is stuffed with insulating fill. Once the skins are slipped over, they're spot welded into place. And you'll notice the ends of these panels look a little differently. And what you'll find out is that inherent in the panel is its attachment or connection method to the adjacent panel next to it. And that's what we look here, an inherent connection and strength. So our panels can be different on the ends depending on what other panel they're mating up to. So the first panel here can be a groove panel. It can have grooves up both sides. Then we can have a groove tongue panel, which is our most common panel, where you have a groove on one end, a tongue on the other, where the tongue slips into the groove. Or you can have a tongue panel. So there's different types of panels that we have, and it depends how they're going to join together. The nice thing about the inherent connection that we talk about is that you don't have additional trim pieces just for putting this long longitudinal joint together, because they slip together. And once they slip together, you can see a tongue panel into the groove connection. Once those come together, they're very strong. It's like a reinforced sheet metal tube steel almost. It's a very strong. So when I talk about connection, inherent connection, but it also gives it inherent strength once the panels are all assembled and connected together. Mechanism of performance. How do these panels operate? What are the functions? What do we look for when it comes to acoustics? So one of the first things you're going to look for is sound absorption. Although a standard, we have a standard media fill that we use probably 90% of the time on our projects, but we can also put non-standard insulation or media fill inside these, and sound absorption and noise reduction criteria is basically the driving standard of this panel's performance, but also sound transmission loss, its ability to block noise. The panel's ability to block noise. Our standard thickness of panel is 2 inch and 4 inches thick. We can go greater thicknesses depending on what the application is. We can go up to 12 inches thick. We use our panels for a lot of different applications, so sometimes we need to go much thicker. But our standard panel, actually from 2 inch to 4 inch to 12 inch, 4 inches probably, once again, probably 80% of what we supply in industry. It gives you that sweet spot of good blocking ability of sound and great absorption. It gives you that good balance based on strength and then economy, the economics of putting such an enclosure or a barrier wall or whatever you're using the panel for. It's the most economic balance. The inner, outer, and shell construction can change. I mentioned in the before, you might have an inner shell that's perforated metal and an outer shell that's solid. You might have both shells are perforated and both shells are solid. And we can also make it with an internal septum that gives you even another blocking mass within the panel to give you higher transmission loss, noise reduction, sound blocking capabilities. I talk about composite performance characteristics. So we just looked at it. We looked at this panel gives you sound absorption, and it gives you sound transmission loss or sound blocking. So that's the composite. It just doesn't do one thing. It does two things that when paired together, it gives you the best noise reduction, noise control that you can get within a single panel or a single product. And if I gave you an example here, we looked at just the 500 hertz center frequency, say, and we have a noise source, maybe a fan inside a built-up air handling unit. And the fan is generating 100 decibel sound power level at 500 hertz. That sound energy is going to propagate through, and that's what it is sound energy is going to propagate through the perforated inner shell of the panel. We kind of show the perforated inner shell here. As that energy then propagates into the acoustic media, then some of that sound energy is going to get absorbed and reduced. And then before it can even impinge or try to propagate through this solid surface here of the outer shell of the panel, that noise energy of 100 dB has already been reduced some. All right, so when you actually exit and break through that outer solid shell, you might, for this example, at 500 hertz, go from 100 dB sound power levels to 61 dB. All right, a huge reduction, and that's due to sound blocking and a function of the mass and the thickness of the panel and the insulation. On the inside, what happens is you get a little diffusion, a little bit of the noise. Then after it hits this solid surface, some is actually sound energy is going to bounce back, go through the absorptive material again, and then some of that sound energy is going to come back into the open space. So you actually, on the side of the noise source, is actually going to be reduced a little bit as well because it gives you absorption. So once again, you get sound blocking and you get sound absorption. And just moving from that 100 dB to 61 dB, that looks, you take the straight difference of that, you come up with a 39 dB reduction, and that's considerable. All of these products, these noise block panel products, different configurations, they're all independently tested. Independent testing is extremely important to Kinetics. It's costly. You're not going to run something 100 times and take the best data. Instead, you're going to run it once per the applicable ASTM standard, the C423 for standard method of testing for sound absorption. ASTM E90, standard recommended practice for laboratory measurement of the sound transmission loss of building partitions. And they're all in a NAVLAC accredited laboratory. So what I always like is that we publish the data we get. We don't run it a bunch of times, look at the variances or the potential variances, and then give you all the best data to make it look super. We're going to give you real life data, something that acoustical consultants and architects and engineers can really stand behind when they're using it to design their systems. When you look at various construction and performance, we do publish data on whether you're looking at sound absorption, which is the top chart here, different thicknesses like the 2 and the 4 inch, different models, this one has an 18 gauge solid 22 gauge perforated inner shell. We have a 16 solid 22 inner shell. This is a 2 inch thick, this is a 4 inch thick. And the last one actually has a perforated inner shell, solid outer shell. Then it has an additional solid septum at that midpoint between the 4 inch thickness. And that gives you even more noise control. But the key here is that we publish data for you to use. This is just a small sampling, but probably the most commonly used product. And that's why we use it in our literature and we publish it. But we do have more on hand. Then we can also look at the transmission loss, the ability to block the noise, right? So the higher the number, the better. And these are all in decibels, and it gives you, per the standard of ASTM E90, it gives you the standard 125 hertz through 4,000 hertz. However, we can extrapolate those for those that want to look at, well, what's the 63 hertz data? What's the 8,000 hertz data? So we publish all that, and then we have additional information in-house to help you with. Now, achievable noise reduction, you can say, well, yeah, these panels are great and they obviously work well, and the physics behind them makes perfect sense, and they have a lot of history that we've used them for years with great success. But if you're looking at them to use a barrier wall system to us is a walled system, let's say a 4-walled corral or a system around some air-cooled chillers or a fan or some manufacturing process. But it's let's say 4 walls, okay? It doesn't have a roof. So a barrier wall system's open top. So we're going to look at a lot of that noise bouncing around inside, noise trying to propagate out the sides of the panel product. But also we look at the up and over noise. How much noise propagates up, over? Where's the shadow zone, the real quiet zone when you get close to a barrier wall system with an open top? And then what happens to that up and over noise as it propagates further away that might affect a receiver. Now we're looking in a shadow zone where you're standing very close to the barrier wall, the wall system. You might be looking at high as a 20 to 25 dBA reduction. But then as you get farther away beyond your realization or your max realization point is about 10 to 12 dBA reduction. If you look at a full enclosure, take that same barrier wall system, put a lid on it of these panels, you can look at typical noise reductions of 35 dBA. Now, of course, we can do more by changing the panel style and the configuration and all that, but on average, your day-to-day, you're looking at a 35 dBA reduction. We can tune them, though, if you need 55 dBA. But just to let you know, now, you're saying, well, John, you're talking about these dBAs. I'm not really sure what they mean. Well, it's a logarithmic scale, and in green here, I have bubbled, basically clouded, that a 10 dBA reduction is going to be perceived by the average human as sounding half as loud. So if you have something at 100 dBA and you reduce it only 10 dBA or to 90 dBA, that doesn't seem like a lot. And it may still not be quiet enough per OSHA standards, but you're going to perceive that as, wow, that's half as loud as it was before. So it's significant. Panel construction and finish. There's a lot of different things we use. Our most common are listed here. Galvanized type G90, galvanneal A60 for a paintable surface when we're going to paint it, stainless steel types 304, 316, and aluminum 3003 H14. So these are the day-to-day most common. You're probably looking at 60% of what we produce is using either the galvanized G90 or the galvanneal A60. Only difference is A60 gives you a beautiful finish to readily accept paint. Acoustic media, we have acoustic media that's, in fact, we use it on everything now. It's suitable for wet, dry, freeze, thaw cycling. So it's almost like a wick-away product. As the media is filled within our product, our panels, it does get set under a proper compression. Not too much compression, not too little, because we want to make sure that it avoids sagging in the panel. If it's like a wall panel or something, we don't want that material to sag. So there's a critical density, and then there's also a critical amount of compression that we put into the system when we build it. Proper density, and it says there on the third item. But the finish, we have different types of finish. We have factory powder coat, we have polyester TGIC, we have wet paint, which is like the Kynar, the Duranar, depending on, and Fluoripon, depending on who the manufacturer is of the paint. And then we can also offer just the mill finish from the factory, that gray mill finish. If you look at our barrier wall systems and you look at these noise block panels, coming back to what we're talking about are the noise block panels. They're modular. They come out to the field all piece marked to match an installation drawing. And then this is a similar ways that they mate within our columns. This is when we use W columns and structural columns, which we design at Kinetics because we have our own structural engineers on staff, because that's, we're big in the seismic, we're big in the wind, we're big in structure-borne vibration. So we have our own structural engineers on staff that then take the strength of our panels, mated with the local adopted IBC, and then we design the barrier wall systems. Usually freestanding is what we shoot for, whether it's a 6-foot tall wall or a 40-foot tall wall. We can handle that, and we manufacture all the structural steel within Kinetics as well. But anyway, getting back to where the panels go, they fit nicely into the column joints. All these structural steel items that we design with our panel systems are all bolt together. So all these nuts, washers, screws, everything, they're all bolt together, so you don't need any field welding, and that's just a real really nice when you're installing it in the field. Sometimes people design their own structural steel, and they'll say, hey, we're up on this roof, we have this big area where we want to put up a barrier wall around our equipment yard on the roof, and we already have our tube steel up. So we have different methods of attaching our noise block panels here to their steel. So we can take all that upon ourselves to help that engineer, contractor, design, build engineering contractor determine what they need to attach our product to their system. If it's an indoor enclosure or an outdoor enclosure, once again, it's all modular. The panel comes all cut to size. You don't need the field cut. There's trim that comes out to cap the edges. And this system here that we're showing you is very exaggerated, but I wanted you to know that, you have a base channel, you have panels that go into the base channel, and then you have cap trim that goes on there. This is all formed, and you connect it with tech screws. And in some cases, we can actually, if you don't want to see the tech screws, depending for our barrier wall systems, whereas in closures, this all comes together. You put the tech screws in, and that's where you get all your strength working. But sometimes on barrier wall systems outdoors, we have cap channel flashing that goes over the structural, so you don't see the structural. And in those cases, we're actually using a two-sided tape meant for outdoors. It's a beautiful thing. It's amazing where they've come with a lot of these products. You can show some roof panels going on. Everything's piece marked. So whether this is a built-up air handling unit, whether it's outside air intake plenum, whether it's a generator enclosure, whether it's an equipment factory process enclosure, they're all the same. Same product, noise block. Accessories and services, we can do removable panels or removable wall sections, hatches, completely removable roofs, single and double leaf access doors with windows, heavy duty hinges, panic passage hardware, passive and active ventilation. So Kinetics is huge in our knowledge of ventilation and knowledge of how equipment operates. So a lot of people will say, you're going to put this noise block sound enclosure around our piece of equipment. Well, it's going to overheat. It's not going to breathe right. It's going to shut down. We take care of all that. Okay. We analyze all that, all the BTUs given off and how much ventilation and the temperature rise. We take care of all that. And with that system, whether it's passive or active with using a noise block panel system, we can also have our own Kinetics acoustic silencers or acoustic lures to vent and keep those air passages silent, those ventilation passages. Structural steel support, we supply and design it. We can PE stamp. We have most 50 states covered. And on the structural design itself, and then piece marked installation drawings, which I think with every job is awesome. We piece mark our product, we piece mark the drawings, makes it very easy. And then we also can do with between Kinetics reps and us, for noise block systems, we can do consultations with the installing contractor before they start. So with all that being said, I wanted to just show you a few pictures of projects showing you one product, noise block panels, that can be used for many different applications. And this is a barrier wall system. I'll admit, I think they were trying to match the brick. It's probably the only red barrier wall system that I remember Kinetics ever powder coating. But it's a beautiful system. It's 20 foot tall, got some simple double doors and single personnel doors. And there's a corral. You can see there's a lot of equipment. It's got a perforated inner shell with media in it that can be suitable. Look at this, is snowing here, but it can be wet, dry, freeze thaw cycling. We also have a rooftop equipment yard at a hospital. We got a bunch of high-rise complex over here, apartments, I'm sorry, but they were hearing a lot of the noise. So we were able to work with the architect, work with the engineer, local rep, and installer, and come up with this noise block panel solution. This, once again, is perforated inner shell to absorb, and also a solid outer shell with a nice factory finish. It's a project 30 foot tall around a cooling tower. And you say, well, where's my ventilation ports? How's the cooling tower going to ventilate? Well, behind this, in the background, is an open area parking garage. So it was able to pull all the air in from there. Everything was produced at Kinetics. This happened to be shipped down to Puerto Rico. And over here where we're standing, over where the blue, if you can see my blue pointer here, those are also condos and balconies. The building over here was extremely happy because they got a new cooling tower. The people over here were not happy because they heard the cooling tower. So that's where we come in with our noise block panels. This is an air-cooled chiller stack. Another place we use noise block panels. These are all 4-inch thick, all perforated, the perimeter, perforated inner shell, solid outer shell. And then we put these divisional panels in here. They're perforated both sides and basically are working as absorption chambers, sound absorption chambers. Really cool. And none of this touches the air-cooled chiller. Takes care of all that low to medium frequency noise, like 500 hertz and below. Takes care of all that drone noise. And we designed the frame to separately. Now, a lot of people, we do offer an option for access ports in here. A lot of people don't spend the extra money. They figure if a fan goes, they will, because this is typically at most 5 foot tall, this panel, they will hoist a fan out if a fan blows and they need to pull it. but access ports are available. Here's another air-cooled chiller you see mated with other, it is an air-cooled chiller, but it's mated with other Kinetics product like acoustic louvers in the doors, but these are the noise block panels and steel system. You know, built-up air handling units. I never have gotten a real good picture of a built-up air handling unit, and half the time when they are together, they're hidden in a mechanical area or that, so I'm using these drawings here. I'm sure you won't mind. It's the point that matters. Or air intake plenums. This is a generator yard where they had generator enclosures around multiple generators, but they were still too loud. They were using even hospital grade engine mufflers, silencers, engine exhaust silencers, and it was still too loud. So we designed a barrier wall system. And this is neat because it's got the Kinetics blue. That's not why it's neat, but it's Kinetics blue on the structural steel, but it also has a mill finish. So they didn't want to spend the extra money. This was retrofit on the factory painting. So they have a mill finish here. It looks pretty good. And that will hold up pretty well. A galvanized G90 coating will hold up pretty well over time. But if they decide they want to paint it after a few years, they can. This is just a midstream compressor site, a bunch of midstream compressors on the other side of this wall. You see the header here on the white piping, and this is a 40-foot freestanding wall. And in this case, they didn't need to paint it, but because we didn't want reflection or hot spots on site, because it's a midstream compressor, gas compressor site, we actually use more of a dull finish here. Okay, so that's really important. We also, in a factory, here's a stamping press and they wanted an enclosure. Once again, we use the same panels to make these sliding doors, the same panels to make the enclosure itself, and all the strength within this enclosure because of those tongue and groove joints. So we don't have to use as much structural steel to support the enclosure. Once the enclosure is all put together, it works all together as a membrane, and there's a lot of strength there. Municipal pump enclosures for outdoor applications. This is a desalination plant enclosure. They needed a lot of ventilation, kind of looks neat. They also wanted to walk on the roof, so this one has inherent additional structural steel in it. And we actually had to, this is over a well here area, which is very weak. So we had our Kinetics engineers had to design a special framing system within this to draw all the weight and forces out to this wall and the other wall, and the end walls, nothing could be over the center. It was very, very unique design, but Kinetics engineers are able to do that. A big generator and cogen unit. You can see all the noise block panels there on top of a foundation. Midstream compressor enclosures. You can use this for just about anything. Test cell enclosures, test enclosures. In this particular one, you have the acoustic doors and windows, but all of this is all of our noise block panels in the system. And then they came in later and field painted it. Middle of a factory, shoehorning in, there's a noisy piece of equipment, noise block panel enclosure. Specialty skids, specially painted. We have a noise problem wherever we're going to put this system. It needs to be controlled, maybe 85 dBA at 1 meter. And so we do all the acoustic louvers, but look at all the noise block panels, all designed to fit this customer's skid. And I think that's what's important. We're not just stuck with a certain size panel and everybody has to buy it and it's got to fit your system. No, we design them to fit your system. And then what I'm always want to tell you, because I think it's important, because I don't always see product being shipped properly from various places. At Kinetics, we take a lot of pride in what we make. So you can see all of our noise block panels here. Remember I mentioned they're all piece marked. So even when they're painted, they would be piece marked on the ends. That'll all be hidden after installation. We do some pretty hefty protection for shipping. And then here's a bunch of actually powder coated trim pieces on another job that was all banded, sealed, and protected. So I think that's very important. So once again, Kinetics, we create quiet, cruise quality of life. That's what we do. That's all we do. And I think that's interesting. And so noise block panels, we'd like you to spec them. If you want to spec from us or you need information, contact your local rep, contact us here in the ICE team, contact me, and we'll help you design your next noise control system, whether it's a wall, chiller, noise control stack, or an enclosure system. I would like to thank you all for joining me. Have a great week and even a better weekend. Thank you.